So we are
Get started recording. Hi everyone, this is for the gate preparation for 2025. Welcome, and we have Nikhil More who is going to handle the relation to engineering mathematics. We started looking at it, and we wanted a really good introduction from him, and we hand over to Nikhil More. Nikhil, go ahead, take care.
uh, yes. So I have shared a website. Can you see it?
Yeah, we can.
Okay. This site it gives an introduction about it is sort of cheat sheet for linear algebra, and it would help uh, to have a collection of all the required, right, this one, required formulas at one place. So how many are there online right now? We have five.
Yes, we
So
are there. What you do is, if you have any uh, link to put on the chat window, it will be perfectly all right to put the link there so others can use it later.
yes, sorry, just add that to the chat here.
On the chat window to all, you just copy paste that link
Okay.
so we know that we will be using that.
All right. So as we start with linear algebra, we'll start with some basic information about linear algebra. We will start with vector and linear algebra actually. For that, we need to have the basic knowledge about some operations and properties of determinants
Mhm.
of linear algebra. So first key point is that we need to know what determinants are. So a determinant is basically, if we know, it is we perform some operations on the matrix elements, and we need at least a 2 by 2 matrix to calculate the determinant of the matrix, and it is valid only for a square matrix.
Okay.
The properties here says that A transpose, the determinant of A transpose is exactly equal to the determinant of A, where A is an n by n matrix.
Okay.
The second is transitivity in multiplication. So, determinant of uh, dot multiplication of AB matrices A and B is equal to the
Determinant of A into determinant of B.
thing.
Yeah.
Um, so if we put A in place of B in the second lemma, we could just extrapolate that A into A will give you the determinant of A into A will give you determinant of A into B. So again, expanding that to A raised to n, we get the determinant of A raised to n will be equal to the determinant of A, the
Okay.
whole raised to n.
Good. That's good.
Uh, Again, this is, as we know that the determinants are valid only for a square matrix. The determinant of k multiplied by a, where k is the scalar, it is a number, and a is the matrix. The determinant of k into a will give you k raised to n uh, multiplied by the determinant of a. So as A is always an n by n matrix. So we need to keep these properties in mind while doing the solutions. Uh, Again, if two rows or columns of a determinant are of actually of a matrix are interchanged, the sign value of the determinant changes. It's basically comes from the definition of determinant, because by definition it is like minus 1 raised to uh, n. So it actually, if we change the rows, you will the sign will definitely change, because at least one element in the row would change its sign. If any determinant in row or column is completely zero, the value of the determinant is zero. Uh, Again, it comes from the definition of determinants. If you know, I'll try to give the solutions also. And if two rows of a or two columns of a determinant are identical, the value of the determinant is always zero. So these are some of the properties that we need to keep in mind while calculating the determinants. Um, the When we carry work like we move forward to matrix multiplication, three basic properties that we need to keep in mind for matrix multiplication is like if A, the matrix A is an m by n matrix, and we need another matrix where the uh, B will be n by p matrix. So we need to have the column of the first matrix and the number of rows in the second matrix to always be equal. If they are equal, then only we can perform the matrix operation on the multiplication operation of the matrix. So if we take A as m by n matrix and B as n by p matrix, and we multiply them, then the resultant matrix will always be of the order m by p. Um, it just says that the number of elements are m by mp because it's an m by p matrix. The number of multiplication of elements in these two columns would be mp into n, and the number of addition required would be, these are the basic addition multiplication property within two matrices. So let me see if we can take some questions over here. Right. I think before we go to the mathematicals, we'll go to an important topic, that is eigenvalues and eigenvectors. Eigenvalues is defined by lambda. It is just lambda where we have any matrix A, uh, then A minus lambda I, where I is the identity matrix. So identity matrix where all the diagonal elements are 1 and all other elements are 0. Then the eigenvalue lambda is such that the determinant of A minus lambda I will always be 0. So this is a very important property of eigenvalues. It is actually the defining you can say parameter for an eigenvalue. What is this? They are calling it as the characteristic equation of the eigenvalue.
So eigen is a German word for own. So that
Okay.
is the characteristics, own matrix. That is characteristics of matrix uh, is nothing but if it is a what you call a matrix, and if that matrix own characteristics show up, this a minus lambda, lambda is the constant, any real value. It's a constant, it's a scalar value basically. So if you subtract uh, a or a is equal to lambda into identity matrix. So when you do a subtraction a minus lambda I, that is you are bringing from the other side, and you are taking determinant of that, and that should be 0. Then only you can have. So it has some interpretation in the sense that if you talk about metrics and they are in the same span or something,
Rank.
then only you can get this. Otherwise, not. So basically, if metrics are all over the places, vectors are all over the places, then you don't get that constant multiplication. So Example in vector, we say if you have a line, you have a line and an arrow in that line, you can do anything, that is multiply by any scalar, whether plus or minus, it will be on the same line, right? If it is on x, it will remain on x. If it is on y, it will remain on y. There is no in between, right? Same way, this has some connotation like that. That's what I understood. Okay, but that's a more of an interpretation. But to remember that you have a matrix, and if you have a eigen, every matrix does not have what you call uh, a eigenvector which is unity or which is scalar and which is real. Okay, if it is unreal, then that means it has imaginary axis, right? We don't want that.
Okay.
Scalar, when we talk about lambda, this is, I think I'm talking about only linear scalar, that is real number. So as long as it is real, you will have some vector, eigenvector and eigenvalue. There are two parts to it, eigenvector and eigenvalue. I think you go ahead now.
Yeah. So the next line says that if an A has n eigenvalues, uh, and x is a vector over here, the eigenvector, then if we sorry, so x, yeah, so x is the eigenvector here. So what it says that a there will also be a vector x which will give you the determinant of a minus lambda I. So this is quite confusing while reading it. So when we solve the first question, it will be more clear about what it is. These are the some rules that we need to keep in mind. But I don't think it is critical here for the gate solution. So I think we could just start with the sums and tackle the properties as it comes across, right?
Yep.
Yeah. So what I'll try to do is just start the video. I think I need to. Right. Okay. So this is here. Uh, the first question that we have over here is that we are given some eigenvalues, and we are given eigenvectors. I hope this is visible, right?
Can we put it in full mode?
Uh,
I don't know whether we can see it in full mode, but that's okay. I thought you're sharing, right?
yes, yes.
Can you put it in full mode?
Uh,
Hey, try.
it's actually okay. I think I need a better pen.
Maybe it's not.
Just let me check with the pen. I'll be connecting back.
Yeah.
So
Nikhil, are you in the full mode?
yes, I think you could change to full mode.
Okay, I can change full. Okay, I can.
So we have eigenvalues given, and we have eigenvectors. Uh, the eigenvalues are lambda 1 as 8, lambda 2 as 4. Eigenvectors corresponding v1 is 1 1, and eigenvector v2 is 1 minus 1. The given A, we don't know A, and they are asking us to find what is A, right? I'll just snap a photo and share it.
Eigenvalue A1 equal to lambda 1 equal to 8, lambda 2 equal to 4, A is a question mark. So they are asking for, given the vector v1, v2, 1, 1 and 1 minus 1, they are asking what is the matrix that will be matching these, uh,
Right.
correct? But where are they? They have not shown any, they have four numbers, right there?
Yes, yes, there are
Four
four
matrix.
numbers. So the question over here
Yeah, yeah. That's good. That looks good now.
is this one.
Yeah, so you got lambda 1 equal to 8, lambda 2 equal to 4. You got vector v1, 1, 1, vector v2, 1 minus 1. And the four matrix A, B, C, D are there. We have to select for this 2 by 2 matrix A, which one satisfies this two lambda values, which is the AI minus lambda equal to 0, which will satisfy this, right? Where A is the matrix we want.
Yes.
Okay. So now go ahead.
Yeah.
And,
So we have the definition of lambda of eigenvalues, right? Which,
so So explain that there are two eigenvalues for the given
yes, right.
matrix,
So
and the eigenvectors are two vectors. Two
right,
eigenvectors are there.
right. So they have mentioned that there are two cases where, in one case, just put a box around the first case. So this is the first case. The first case says that the lambda 1 is 8, where the lambda vector v1, as in the definition, is 1, 1, 1. So I'll just solve for case 1. Solve for case 1. So we have um lambda 1 as 8, v1 as 1, 1, and a we don't know, but we know that so I just put a block over here. But we know by definition that A minus lambda I lambda 1 into V1 will be a zero vector. This
And
is
A
by
is a 2 by 2 matrix,
Yes,
correct?
A is a 2 by 2 matrix because eigenvectors can be only for n by n or square matrices. So what we'll do, I'll just name this as A1 1, A1 2, A21 and A22. Uh, Keep in mind that this A will be constant for both the cases, for case 1 and case 2. That is what we have to keep in mind, right? So we have A. Now we'll just replace the values of A, which we have to find. The lambda we already know. I is the identity matrix. We just keep a mention over here. The I2, this is actually because we are doing it on a 2 by 2 matrix. So 1 0 0 1. Identity matrix is defined as the matrices where the diagonal elements are 1 and all the other elements are 0. So we have just 2 by 2. We get 1 0 0 1. Uh,
So we call it as diagonal being 1, off diagonal being 0.
yes.
Okay.
Uh, so we'll just replace whatever we have into this equation. We replace A as A11, A12, A21, and A22 minus lambda 1. We definitely know that lambda 1 is 8 and I is 1001 into V1. So the whole would be multiplied by V1, which is 1 1. This gives me a 0. So uh, 0 matrix over here actually. We just multiply, do the multiplication. Next step would be multiply this 8 and we get is A11, A12, A21, and A22 minus 8008. This is the basic multiplication. Next would be just subtracting it. This gives me A11 minus 8, 0, not 0, A12. It should be
No.
A12 minus 0, so that will be
Sorry.
A12.
Okay.
This will be A21 minus 0. This gives me A21, and A22 minus 8. So 1 1, it gives me 0 0. Now the next step is to perform the multiplication. We do the multiplication over here, the matrix multiplication. So it gives me
A11.
A11 minus 8
Mm-hmm.
into 1.
Mm-hmm.
A should be plus, right? A11, yes, plus
So top row by the there is top row by the
a
column.
top row by the column. So
Yeah.
this will give me A1 2,
A12. Yeah. A11 minus 8 into A12.
and the lower element would be A21
Into
plus
1 plus, yeah,
A2
A22 minus
minus 8
A22 minus 8. Okay.
gives us 0 0. So that actually implies that A11
Mm-hmm.
8
Minus 8.
plus A12 is 0, and A21 plus A22 minus 8 is 0.
So two unknown, how many? So the chances are what?
So actually from here also we could take a chance on the option. I'll just
Yeah.
or I think I'll just solve it completely,
Mm-hmm. Yeah,
and
go for the second one also.
yeah, I'll just uh, do it just for the clarification of the steps here. We have lambda 2 as
4.
4, and v2 as 1 and minus 1.
1 minus 1. Yeah.
A should be the same one, A11, A11, A12, A21, A22. The same definition applies over here, but with
Lambda is 4. Lambda 2 is 4. Yeah.
yes. So A minus lambda 2I in this case into V2 will always be a 0 matrix. Replacing it, we get A11, A12, A21, and A22 multiplied by 1 and minus 1. It will give me 0 0 matrix. Solving this, let us see what we get. Sorry,
What
we get,
happened to lambda?
yeah, it should be there.
Yeah. So
So sorry. I'll just do it again. Increase it here. A11, A12, A21, A22
mhm.
minus
Minus, yeah.
the lambda 2 is 4.
4.
So we get 4. I'll just skip this step over there
Mhm.
because we did it in the last.
Yeah. So I multiplied by lambda is lambda I, and that is 4. 4004. Yeah.
And this will give you a 0 0.
And that will be V. Okay. So A into
A
A
minus
minus
lambda n
I.
into V2, the whole into V2 is 0.
So identity matrix is multiplied by lambda. That is how it comes to diagonal matrix as 4, 4. Yeah, go ahead.
So A11, this is again minus 4, right?
A1 to,
A2, A21, A22 minus 4,
and that has whole multiplied by 1 minus 1.
1 minus 1,
That is equal to 0.
0, 0.
So now you will get equation A1, 1 minus 4
This
in,
is A11 minus 4. This will be minus A2.
yeah.
So A2 is multiplied by minus 1. So here it becomes
So
minus
by
12.
A21 by 1 and
A21. And
yes,
this will be minus minus. So
minus A22 plus
A2.
4 minus A2. Yeah.
This gives us 0.
Okay, good.
So we have A11 minus 4 minus A12 as 0. A21 uh, uh, plus 4 minus A22 as 0. And from our previous this thing, I'll just copy this over here. What we have is A11 minus 8 plus A2 is 0. A21 uh, minus 8 plus A22 is 0. Okay. If we solve these two equations,
4 equation for 4.
four equations, what we'll get is actually, if you just look at it, what it says that uh, A11 minus A12 is 4, A11 plus A12 is 8, A21 minus A22 is minus 4, and A21 plus A22 is
8.
8.
So you have moved all the constants to the right side, and that gives us the same 4 equations.
Yes. And now I think I'll just open up the page again to see the options that we have. So I'll just keep it close by. Uh, we can, or better, I'll just write it over here. What options we have? The options they have given are A is 6 2 to 6. Option B is 4 6 6 4. Option C is 2 4 4 2. And option D is 4 8 and 8 4. So now what we can do, we can just compare these options with the four equations that we have. So what it says that A11 minus A12 should be 4. So in this case, I think 6 minus 2 will give you 4. Okay, so this is one probable answer. 4 minus 6 won't give you 2, won't give you 4, so this does not qualify. C says 2 and 4, so 2 and 4 the difference is minus 2, so again this does not qualify. 4 and 8 also gives you minus 4, so this also does not qualify. So the correct answer should be 6 to 2 6, that is the option A.
Fantastic. Very good. Anybody, any questions? I hope you understood what
Right.
exactly was intended, because otherwise it is very confusing the way they are solving. They are just saying, oh, first one you try. But why should we try first one? Right?
Yes. And now what actually the trick over here is that because we want to get it cleared very fast, as we saw here, only the first equation just solving the comparing the first equation helped us solve the answer or get estimate the correct option. Then what should have been done is that instead at the first place only, just when we had solved for the first case where lambda 1 is 8, we have already got this equation where a11 and plus a12 is 8. So we could have checked over here and not seen that we should stop at the first run, but we could check over here if there are any elements that satisfy our conditions, and then we would not have to solve the second part also. Just by solving the first for lambda 1, uh, lambda 1 is 8, we would have already got our answer. So it is actually a test of doing it quickly and doing it rationally. So it's not just mathematics but also rational thinking that needs to be applied over here in this case. So anybody has any questions right now?
Go ahead.
Was
Anyone? Jamit? Okay. Anybody else? Looks like nobody has question. I think Tanishk, any question? No questions. So let's move on to the second topic. So eigenvalues, eigenvectors are clear to everybody. First thing is eigenvalue. Second is eigenvector. Okay, these two are separate. Eigenvalues are some real numbers. Okay,
yes.
and that is a scalar. And eigenvector is a specific vector associated with the eigenvalue. So a solution to a given a matrix can have many solutions. Given a matrix can have multiple solutions for the variables. That is, if you have n by n, then there may be n solution, n variable, n what do you call answers. But the answers that are going to be scalar, and when when you get them as part of the vectors, and then that those vectors which represent that is one part, and the value which they show as a result, that is the solution is the value, and vector is the eigenvector if the solution is real and it's non-zero, right? Even if it is zero, it's okay, but then at least one non-zero we should be have. You can have solution as a zero because that is the only one, but that is trivial, right? I hope you got it, and if not, we can you can go and look back at the definition where on the link what is the eigenvalue and eigenvector, because this eigen will kill you literally every time. It will be eigenvector, eigenvalue, so you don't know what it is, and that is why it is very important to know that if you have a vector has two bases, then it is a x and y axis are the two bases. If you have m dimension, there will be m vectors. So you can have 2 dimension, 3 dimension, n dimension. But as many dimension you have, so many bases you'll have. That means what? Every dimension is at least orthogonal. That means x is, if you take a Euclidean xyz axis, they are orthogonal in the sense that they are perpendicular to each other. If you draw a line, it doesn't have any component in the other two lines, right? Other two axes. Same way, if you do instead of x, you have a y value and no x and z value, then it is orthogonal. Only it is only going in the direction of z or z. So if you have more than 3 dimension, then it becomes tensor. So you can have a time direction. Let's say time is another axis besides the space x, y, z. So then there is a fourth axis and they are all orthogonal. That means what? Time will not interfere with your x, y, z. And it can also be r, theta, phi, any type of coordinate system. We don't care what it is. So the dimension can keep increasing, and that dimension vector space is if you have a line representing a vector which is from uh, a point to another point, but rather you say that it is a distance, and that distance, so it is measured by distance and direction. And you can always locate it at origin, that is 0 0 if you want on a coordinate system. It doesn't have to be, but that is the representation usually acceptable in most mathematics, physics, as well as in chemistry, or for that matter any of these other domains. So that's the clear picture. Vector space, or what you call, then we'll go to matrix. Matrix is nothing but a representation, scalar representation of the vector. It could be n by n dimension. So it's an array types, but array with rows and columns. So you have row vector and column vector. Combination of that is the matrix. And of course, matrix is what you call directionless. It's just a scalar part of it. Yeah. So what we have done now is made sure that you'll have one question on eigenvector, eigenvalue, you'll crack it. Because every mark matters. Even if you have one session and 3 or 4 questions you have solved perfect, that will be the way to go about it. So on the same note, do you have that linear algebra portion? You can show one more,
Yes.
one of those which we will probably attempt.
Right. I am taking a numerical question now,
Okay, yeah, go ahead.
which is from 2017 set 1. Yeah. So here it says they have given us a matrix A. Matrix A.
Can you show on the screen?
Yeah, yeah, I'm sharing it on the screen.
Oh, you're sharing on the screen. Okay. Yeah. Here's a matrix A 3, 2, 4,
3
9,
to
7,
9,
13.
13, minus 6, minus 4, and minus 9 plus x. They say that it has 0 as an eigenvalue. And given that, you have to find the value of x. So again, let's go back to the definition where we get the eigenvalue. So we have a minus lambda I will be the determinant of a minus lambda I will be 0. But they have said that 0 is an eigenvalue. So they're actually saying that lambda is,
Bring the paper down a bit.
yeah, right?
Yeah, yeah, and sideway, right side. Oh, no, no, not the other way around. Other way around. Ah, yeah, 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 yeah. Now it is.
Right.
So this is the A,
This a,
find the value of X.
yes, find the value of x, and they're saying that lambda is 0. Lambda
That
is
is 9 9 plus X, that is.
minus
Okay.
plus x.
Okay. So you got 9 minus 9 plus X as one term in the matrix, and we are trying to determine the X.
Yes.
And that X we are determining using this formula, which is A minus lambda I equal to 0. Lambda equal to 0. What is it? Lambda equal to 0, lambda equal to 0 twice you written.
Given that this,
They have given this?
yes, yes, they are given that a has 0 as an eigenvalue.
Okay, okay. A 0 is the eigenvalue. So lambda is equal to 0.
So lambda is 0.
Okay.
We'll just replace this and solve it to find the value of x now.
So lambda I will be then all zeros? Zero matrix?
No.
Mhm.
Yeah, so this will be 0, no? So
Yeah, lambda into I is 0. All.
for lambda is 0, so what they're saying that lambda into I will be 0. So a minus 0 would be a.
Ah, A minus lambda equal to 0. So A will be equal to 0.
Yes. So we have to just find the what they have cooked up such a thing that they would have actually clearly said that the determinant of a is zeros and find x.
Hmm.
Instead of saying that, they are going, they're asking us to think about eigenvalues
Hmm.
and then find the determinant of A.
So the assumption is here that if a matrix determinant of a matrix is zero, then what is the conclusion?
So we can find X. We have
Yeah, okay. No, first you say if determinant of a matrix is zero, what does it signify?
uh,
That means eigenvalue is zero, or what does it mean? What is it they are asking?
no, they have said that eigenvalue is zero. It is
Okay,
different. It is
okay, okay, fine.
often they're asking to find X,
Value of x.
the value. So we can just start with, like, it's just basically thing. I'll just rewrite over here.
So calculate the determinant of this matrix and solve the x, solve for x.
It's equals to zero, but lambda is zero. So we have a minus zero I is zero. So this actually eliminates. This is all determinants. So determinant of A is zero.
Yeah,
Is we find out.
correct.
Now we'll just try to find the determinant of A. So determinant of A is 3, 2,
By
9, 7,
so
30.
we can solve that particular column, right, where this is x. That
Uh,
should take care of it, right, automatically. One equation should do, right, because there is only x, only one unknown. One equation should solve the problem.
one question should solve, but it's not. You have to find the determinant, no?
Okay, okay, okay. No, I thought that even with one equation you can solve the problem if it is possible. I don't know. So if you do the middle one, 2 top, and on the sides you take this 9, 13, and minus 6 and minus 9x,
Okay.
9 plus x, and that is one equation, right?
Hmm.
No, 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 no. We have to go for the entire thing only has to be zero. Okay, go ahead.
And the determinant. It is not the vector thing. It is what. So we'll just solve it. So this is 3 into.
Multiply that, you can write down directly, right? Just show them 3 into what plus what minus what into what or something.
3 into, okay, 3. So
And then 7 into minus 9x, right?
7
Yeah,
into
this
10 to the minus
one
8.
and this one, yeah. So it will be 7 into minus 9.
7 into minus 9 plus x.
Yeah,
A minus b, correct?
minus plus minus 12.
13 into minus 4. Okay.
Oh, minus 13 into 4. Yeah, 13 into minus 4. Yeah,
Minus
that
4.
is one plus.
A, this is plus, so that should be minus 2.
Yeah, yeah, that is one equation plus you have to say, right? Or the second is minus.
Minus, second would be minus.
Okay, minus 2 into.
So 9 into minus 9 plus x.
Correct. So odd, the column which is not representing the
Right.
2 1. So on the side you have got two, those two. So yeah,
Uh, into minus of 13 into minus 6. And then plus 4 of 9 into minus 4 minus 7 into minus 6. So we need to just solve for this.
what does, yeah, just go ahead and solve it and tell what it is. So we
3 into 7 9 are 63
yeah, those who are on the call, if they can do it on their own on their sheet, that will be easy if you can follow.
plus 7x minus 13 fourths are 52 minus 2 into 9 is minus 81 plus 9x minus 13 into 6 is 68, 78. 4 into 9, 4 is 36. So this gives me minus 36, minus, uh, minus 56. We just solve it. It is just basic mathematics over here.
Mhm.
Mm,
So overall, what does it come out to?
so it will come out to something. We will have to just solve for it.
Mhm.
9, 21x plus 2. This is minus minus 2 into 9, 15, minus 159. Next is 4, 20, 4 into 20, minus 159, plus 21, x, plus 2, minus 68, plus 1, minus 18x, plus 8, plus 21 minus 18 is 3x. And I'll just use the calculator.
Mm. Is it coming to zero?
Um, I don't think so. Plus 2, plus 318, plus oh, minus, minus 189, plus 318, gives me 261. We know that
361?
261.
261. So 3x gives you,
So we know that this is 0
yeah, it is not zero. Okay.
because mod of a they have indirectly told us that it's 0
So,
because of a. If
so what is that they have given in
that
the?
that eigenvalue was 0
Mhm.
and
No, what are the options they had? Any options there?
this is a numerical type.
Okay. Okay.
So we'll just solve it. 3x minus 261. So x gives us
So are they talking the answer is real number or some number or zero or unique or non-unique or what are there?
nothing, nothing. It's just a simple this thing. So if you can see this 10. Answer number 10.
Answer number 10. The value of the matrix is 3, 2 has 0 as 0 what? 0? Can you read it? 0 has 0 what?
At 0 eigenvalue.
Uh-huh. So M is what?
So the value of x for which the matrix A has 0 as
So
an eigenvalue is,
is 261.
no, we have to divide it 261 by 8.
So just put it 261 by whatever number.
Yes, yes.
You don't have to divide it. You can put a fraction also.
Yes, it is divisible by 3. I don't know it's correct or not.
Essentially, you are saying you have been able to calculate.
Yes, yes, so we have to calculate this and
So it is 261 by 3 means 3 eights are 3 nines are 27. So 3 eights are 24, 2, 3, 7. So 87.
yes, 87.
Yeah. So the answer is 87. So this is one of the complicated problems, but at least it is calculatable
Yes,
because you will get really uh, questions which will be very, very confusing most of the time. So even if you get one correct, that's score. So you can score in this mathematical portion. So that is another answer to the question. And so we can also look at uh, what you call one problem number 2008 fourth. You have linear algebra.
linear algebra.
Yeah, 2008 question and as a three also 3 and 4 both you can knock out.
Okay,
On the linear algebra 3 and 4 they are simple questions. So at least you'll have two solve.
yes. So I will just start with
Three 2007 3. There is chapter on linear algebra 2007 3.
yes, yes,
If it is given that x1, x2, xm are m non-zero orthogonal vectors,
yes,
dimension of the vector space spanned by the 2m vector x1, x2 is this. So what is the answer? A, B, C, D. Yeah, just go ahead, show that and read it and then we get the answer.
yes. I think there is no this thing, right?
Yeah, it's a simple straight answer.
Straight answer.
Yeah.
Yes,
So what is it saying? It is given that x1 to xm are m non-zero orthogonal vectors. The dimension of this vector space spanned by 2m vector x1 is, right?
yes,
By the 2m vector. So first thing is he's saying that there are m orthogonal non-zero, right?
yes. They're not
Once you have got, if you have two dimension, what is the span? 2.
two.
If it is an m dimension, what is the space? It has to be m straight. So
Yes,
he is confusing by saying 2m and all that. You can put any number you want there. Once you know orthogonal, like XYZ are orthogonal, right? 90 degree to each other. I said time axis fourth, that is another dimension orthogonal. So if you have four of them, then it is four dimension. So if it is m orthogonal vectors, it is m dimension. You don't have to even look at what 2m means or whatever. He can give whatever he wants, but it has no meaning. They are just trying to confuse m plus 1, 2m and dependent on x1 and minus 1 and all that crap. Nothing. It's just, so answer is very simple, straightforward m. Done. Go to the next one.
yes. Uh,
Fourth.
all the four entries of a 2 by 2 matrix are P11, P12, P21, P22. They are non-zero, and one of its eigenvalues is 0. So, which of the following statement is true?
So what you can look at P11, P12, P13, P21, P22 and check on the four A, B, C, D. The fourth one, you will find that first thing is you will find that uh, the P11, P12 plus. So first thing is it has to be in order. There is no if you do something like this, you are going to look at what is the minus out of it. Is there any minus in this?
Yes,
So if you take a P and 2 by 2, P11, P12, P21, P22. So you look at the four of them and what is that you find has a value 0. So the lower two are 0, right?
yes,
Upper one minus minus, so they cannot be the answer. 1 and minus 1 can't be answer. So it is either C or D. If it is C or D, then you check which one is. Um, so if you take them, it appears that P11, no, P11, P12 minus P12, P11, P2, no. is 0 and D is P11, P12 plus. So first of all, there are no negatives in any numbers, right? So the question is, he is calling which of the following is true. And so what we will see is that since we know that we have got to have, if you do some multiplication, you have to have P11, P12 minus P21, P12, right?
Yes.
So C or D, C appears to be correct because that has got the P12 minus, right? Minus in between,
Right.
like a determinant. So you can just blindly put C because you know the first two are plus one minus one, which doesn't meet our requirement. Third one looks reasonably good, and so you can knock it and it will be true
Yes. Right.
because there is no plus. There has to be some minus, right? If you do a matrix
Hmm.
of this, a determinant of this matrix, it should be P11, P12 minus P21, P2, whatever that is, cross multiplication. So there is a minus there, so C is correct. This is a guess, okay?
Yes.
Without doing a lot of work, you can guess it, and then that way we can get. Of course, you should not guess wrong, but simpler one. These two are very simple, right? So
Yeah.
two of them you can knock out like this, nothing, like nobody's business. Of course, the other one, which is, I will skip the, we can even try fifth one, okay? If you look at the fifth one, it's saying the system of linear equations. So two equations are given. Some 4x plus 2y equal to 7 and 2x plus y equal to 6 has whatever is giving A, B, C, D. So the question is it going to be unique solution, no solution, infinite number of solution, exactly two distinct solution? So it's a catch 20. If you try to solve, you get into infinite loop. So what you do is you represent them as a what you call matrix 4, 2, 2, 1, right? 4,
Yes.
2 as the row, next row as 2, 1. X and Y are taken care, forget about it, they are already assumed, and equal to vector, which is nothing but column vector 7, 6. Correct? It's like P11, P12, P21, P22 type. Correct?
Yes.
So now you got 4, 2, 2, 1, and 6, 7. So can we solve this? The question is, and if we solve it, what will we do? So let us try to do a, since this is showing that we need to do something. So what do we do for this? If we try to solve this equation for xy, that is 4, 2, 2, 1, with a column xy multiply equal to 7, 6, right? So maybe you can write that down on the paper.
Yes. Yes.
4, 2, 2, 1, and then into xy, that is xy, and that is equal to 7, 6. So what we have done is we have taken the equation and tried to put it in this way. So we have got, uh, so now what happens in one simple thing you remember, you can reduce a matrix. So example, you look at the row 4, 2, 2, 1. 4, 2, 2, 1 is nothing but multiplication of each other. 2 into 2 is 4, 1 into 2 is 2, right? So basically, this is a matrix where your rank, if you try to determine the rank, it cannot be, the first matrix is not full rank matrix. That means a rank is, so there is some definition of rank I have put down in the, our, what you call the WhatsApp. You got a number of definitions. So rank of a matrix is the either the row, number of rows or number of columns, one of the two. But if you have one of them is 0, 0, you can zero it, right?
Yes.
So if you multiply that is you transform the row 1 minus 2 into row 1, no, 2 into row 2 from R, then it becomes 0. So it becomes, so it is not a full matrix. So that is the definition of matrix. So I'm not even going by anything, just saying if I say R2 and is equal to 2, so that means you only have, you can put one of them as 0. You can just keep 4, 2 and 0, 0. Done. So that means rank of matrix is now reduced. Whereas this matrix is rank 2 and that matrix is rank 0. So you got a unequal ranks, right?
Also on the other side also.
So if you do not have, uh, since since the ranks of one side and the other side are different, you are not going to get a solution.
Yes.
If the rank of two, you don't even have to do anything, just because you can see that rank is 2 and rank is not. So there is a, if you go into the, I'll just read out from what I put in the our group and saying that rank. How do you determine the rank of a matrix, right? So there are certain things which we need to know about the rank, and that is the ranks are defined by how to calculate the rank. So there is some note, yeah, here. The rank of a matrix is the number of linearly dependent rows or columns in the matrix. The rank of a matrix is the dimension of the vector space generated by its columns. It's also the number of pivots in a reduced row echelon matrix. So there are two types. One is called echelon, other is called normality. Normal, if you try to reduce to a normality, that means what? You're trying to equal it to identity matrix. So that means you want off diagonal to be 0, diagonal to be 1. So if you can do any transformation between row by adding, multiplying, or moving rows and something, you can always get some number. And you, there are two ways. If you want to make lower diagonal 0, that is one. If you want to make upper diagonal, that means off diagonal matrix, you try to bring it to 0 by doing some combination of that is subtracting, they call it as reduction. So if you have rows and if you try to do the reduction of rows so that you get 0 elements in it, that is the method, one method, and that is called normal. And the other one is just do some operation so that ranks don't match. And if the ranks don't match, you have no solution. And so the definition is rank of a matrix is the dimension of the vector space, generally its columns. It's also the number of pivots reducing row in the row, in a reduced row. So you, by doing some transformation, you can reduce the row. The rank of a matrix is equal to its row rank and its column rank. The rank of a matrix can't be greater than the number of rows or columns in a matrix. So in either way, we have got only 2, right? And out of the one which has a 2 by 2, we knocked out 1 because 1 we have zeroed out. A matrix is full rank if its rank is the highest possible for a matrix on the same size. So the matrix 2 by 2 matrix should have normally a 2 rank. But in this case, because we are able to reduce one row to 0, it turns out that it is not a full matrix. So matrix is rank deficient if it is does not have full rank. So it's not full rank. So how to find the rank? The rank of a matrix can be found by using the minors. Minors of a matrix is nothing but you are trying to do submatrix, right? And submatrix are, and they should be linearly independent. But in this case, they are linearly dependent, so the minor has gone down. So therefore, based on this, what we can see is we can simply, if you read a little bit more on the rank of a matrix, you will know that if they are not, uh, so if there are two methods, so the Q math which I have linked there, every minor of a, so let's not get into too much. All we have to is how to find the rank of a matrix, and if it is found that they are not equal, that means you have to go with the no solution. So if the ranks don't match, then you are not going to have any solution, and so that is why we put it as. So they are smart. They want to test you whether you know that. That's all. So you don't have to do any calculation. You can knock it down saying, hey, since rank of A and B is not equal, rank A, no solution exists. That's it. So you have to, anytime you find rank unequal, you can just say no solution. And if they are equal, then there may be solution, one or more solution. Whether it is unique, that we don't know. That depends on whether you have, that depends on various things. So basically, they are just trying to knock you off a unique solution, no solution, infinite solution. exactly two distinct solutions, right? So it is the B, no solution. That is my take on that. I hope that is correct. Yes, I think so. B, this what? Two. Uh,
Yes, that is correct.
Correct, right?
Yeah.
Yeah, I think it is correct. So you can calculate any other way, but you don't have to calculate. If you know the rank unequal, done. The next one is a little bit sixth one. It's based on a Laplace transform. And Laplace transform, first of all, explanation wise, I can just give you some idea, but it's not easy to solve, but still we can guess it. I'll show you the guess. Go to 6, show it.
Yes, yes.
So what is, there are two transforms in mathematics which are very popular. One is Laplace transform, other is Fourier transform. So what we did right now when we solved the previous problem was we were just doing we are doing actually reduction. It's a type of transform where you take rho and rho multiplied by something rho. It's called reduction. Reduction is also one of the transformations. But the transformation which happens, suppose you have a time domain. Something is expressed as a function of t, which is time. Okay. And it is discrete, let's say. So that means time equal to t equal to 0, t equal to 10, t equal to 20, 30, 40. We got some samples. So we get some waveform. Let's say you call it ft. So if you get a, a series which is based on function of t, if you want to solve that, you can transform into a frequency domain, and that is called Laplace transform. So if you have ft and if you take a transform of it as frequency domain, then it becomes fs, caps fs. So you transform ft into fs, and there are standard formulas for that. If you have if you have some which is a, so ft equal to a, then the transform of that will always be 1 upon s minus a. S is the representative of frequency domain. So what happens in this Laplace transform is you try, instead of solving something in time domain, you take it to Laplace transform and do it in frequency domain, and then after solving that, which is simple algebraic equation, come back again to um, time domain. And so this is a way of making things simpler, because you, if you look at the question 6, how much complex it is. It says consider a matrix P equal to 0, 1, minus 2, minus 3. The value of e raised to x is a, b, c, d, so many. Okay, so what they have done, they have complicated it by putting it in some e to the something. So if you have e raised to a, uh, then the transform of that is something 1 upon s minus something like that. Some equation is there. But all said, just you don't have to do many things. You see that in the first matrix there are two minus at the bottom. Okay. So which one has minus at the bottom in 2? First one, no. Second one, no. Third one, no. The only thing is D has got minus in the beginning, right? No other has equation minus. These are the only two minus. So since we want minus 2, this is also minus 2, minus 2. Just dump it saying that, hey, D is the guessed answer. And you will find that D is the right answer. Go to 6th and check. It should be D, because you got minus minus at the bottom. You
Yes.
can transform anything, but so basically this is what, S domain transformation are for the differentiation and integration. So you swap the domain. If you are doing d by dt, if you go to the Laplace transform, then you get in the space which is frequency domain. So you will find that since the minus minus is there in the last one, that's a easy guess. It cannot be anything other than that. Am I right? Can you check that? I think so. It should be. Yep. I think it is the correct answer.
Correct answer.
So I guessed it, okay, but you don't have to know Laplace transform, do it, but sometimes it was worthwhile seeing what is the pattern. Okay, so then there is one more, seventh one, right? Eigenvalue of a skew symmetric matrix are always zero, always pure imaginary, either zero or So this is what I was trying to say, that so what is a symmetric matrix? A equal to A transpose, then it is called symmetric. Okay, that means you have a and if you take the symmetry of that, it will A transpose, then you will see in the opposite quadrant. If you are in the first quadrant, it will appear on the second quadrant. But if you have A transpose and you take a negative of that, that means you are doing a minus of that, then it is skew. That means what, instead of going in the same parallel quadrant 1, quadrant 2, it will appear in quadrant 3. So it becomes a skew. It's not a mirror image. It is not a it's not a real this one. So whenever you have got a eigenvalue of a skew, if it is skew, then there is a consequence to that, and that consequence is that you will always get uh, the relation that diagonal elements same sign changes, so eigenvalue must be either 0 or pure, either 0 or pure imaginary to satisfy this equation. Why? That means either solution is 0 or it is imaginary. So solution always 0 will not work because it can be pure imaginary, or it cannot be pure imaginary. It can be either 0 or pure imaginary, so C will work out. Because the reason for that is you have got a skew matrix now. When you have a matrix which is skewed, first and third quadrant, if you take a mirror image, what happens? You look at the mirror, you look at the mirror in a reverse way, right? That's the quadrant 1 to quadrant 2. If you draw a four quadrant, quadrant 1 to quadrant 2 is 8 transpose. Transpose means you are just inverting it, row to column, column to row. But if you are doing change row to column, column to row, plus you are also negating it, that is changing the quadrant, that means you are skewing. It's a skewed matrix. Once you have skewed matrix means it gets into imaginary space. So 0 is always a solution, but now imaginary requirement is required. So therefore, based on that, seventh simple answer is, if you have a skewed symmetric matrix, then either 0 or pure symmetry. C is the answer. Got it? So hope you can crack such things which are very simple. If you know the funda, then you can easily crack it. So that's what I wanted to get you on that this one. So hope that gives you some more ideas. And then is there anything we can look at which will be simpler? I have not looked at into any other, but you can pull off one of them if you have.
No, I think we could hand over to Jaimit.
Zenith is not ready, he said. So let's do one thing. Let's come to the probability. You have equation on probability here? In our no, Jamie, leave it. We'll take care. Don't worry. We have to talk about probability, right? So, what is the chapter on this one?
7.
Seventh one. Okay. So let's see if you have anything on probability. We can knock out a couple of things. First thing is I want to make sure that you understand the dice. This dice problem is a big problem. It always pops up anywhere in the world, and somebody throws a dice, and then you are in confusion what to do next. So it's interesting, and we need to know on the explanation. If we can get, fine. If we can't, at least we can. So let's say probability. Okay. So a fair dice is tested. So first question, let's say. Okay. See, let me explain about dice. If you have a dice and if you have a coin, if you have a coin, then you toss, then you got probability of head or tail. So that means either it is one or it is, and when it falls, then you get one of the two, right? How many times you try, the probability is generally 50-50, right? That's the probability. So that means probability that if you take a coin and toss it 100 times, 50 times you'll get head, 50 times you'll get tail. That's the probability. And probability 50 times is 0.5. So probability is always between 0 and 1. Okay. Now if you have dice, then what happens? If you take single dice and you roll the dice, it has got 6 sides, right? Because 1, 2, 3, 4, 5, 6. If you roll one dice, then you are going to get the probability of any number is 1 by 6. If it gets 1, it will be 1 by 6. Probability that you may get 1 or 2, then it is equal to 1 by 6 plus 1 by 6. So it will be 2 by 6, it is one third. So, so you understand the probability, dice probability as well as dice, because it has six sides, it has to be multiple of that. And the head tail coin is always one or the other. And there are two more factors which you need to understand. Uh, One is called as permutation and other is called combination. Okay. Permutation and combination you learn even in the school. So permutation is what, if you have got n numbers and you repeat them r times, the permutation is n raised to r or r raised to n. What do you say? N raised to r. If you have r, so let's take the combination. Suppose you have got now, let's say, three numbers 1, 2, 3, right? Now repeat this case, but so if I form a number, if I say, if I want to form a two-digit number, then it can be 1, 2, 2, 3, 3, 1, and what else? 1, 2, 2, 3, 3, 1. Anything else left out? Can it be 1, 1? Can it be 2, 2? Can it be 3, 3? Sure. If repeat is allowed, then you can do it, right? And then in that case, so if you allow repetition, that means then it is a uh, permutation, all combinations. So if you have 3, then you have 3 raised to 3, that means the 3, no, 2, this is 3, right? And 2, we are forming of 2. So 2 to the power 3 means r raised, sorry, 3 to the power 2 means 9. So if you have 3 and you have got 2 combination, 3 to the power 2 is 9. So you can have 9, right? Because 9 means how do you come with 9? Because you can have 1, 1, 2, 2, 3, 3, 1, 2, 2, 1, then uh, 2, 3, 3, 2, right? So, and then one more. So this way you can get the numbers, right? So that is permutation. Combination, what happens? You do n factorial into n minus r factorial by some numbers, something like that. C and R. The C, it is called C and this is called P. Permutation is P and R, and combination is C and R. So n factorial into n minus r factorial divided by r factorial. So that means if I take the combination in terms of 3 to 2, then I'll have to do n into n minus r. If you are going to 2, 3 minus 2 is 1, 3 divided by n into n minus r, n factorial by n factorial. Sorry, factorial is 3 to 1, 3 into 2, 6. N factorial into n minus r divided by that is why, so the combination you have to use that formula, n factorial upon n factorial minus. So anyway, both formulas are available. You can check those formulas, that you need to know. So in probability, combination, permutation, and dice probability, the probability of coin toss. And then you have to have adding, if you have a color, whatever you got, what you call a bag with color, red color, white color, blue color ball. If I take one ball out of it, what will be? It's all that, etc. So those are the kinds of things which are very popular in probability and statistics. So let's just at least take one example. A fair dice is tossed, and for that matter, that's why it is important that you know the formulas, okay? And if you don't know the formula, it will cut a sorry figure, because you have to remember the what you call permutation and combination formulas. And so let's take some example, and I would say that I will put some link for you so that you can use those, like NPR is n factorial by n minus r factorial. So we had 3 permutation of 3 with 2 selections, right? So that will be 3 factorial, 3 into 2, 6, divided by n minus 3 minus 2 is 1. So that means we will get six. If we select 2 from 3, you will get 6 combination, 6 permutation, because you are allowing repeats there. But if you do combination, then it will be called NCR. That will be uh, NPR divide, which is equal to n factorial by R factorial into n minus R factorial. So if you are having now 1, 2, 3, and I am trying to find the combination, then the combination 3 factorial is how much? 3 into 2 into 1, that is 6 divided by R factorial. If it is 2, 2 into 1 is 2, n minus R is 3 minus 2 is 1. So then we will get only 3 combination. So permutation will get you higher number because you can do repeats. Combination will give, so if you have 1, 2, 3 and you want to combine 2, the only option is 1, 2, 2, 3 and 3, 1, right? So the combination is 3, whereas permutation is 6. So formula to remember is n factorial upon n minus R factorial, NPR. That means if you have n options, n possibilities, out of which you are only choosing 2, that means if I throw example a dice and I have got 6 options, out of only choosing 1, so it is 6p1, right? And that is 1 by 6 we calculated. And you can even calculate by the formula n factorial minus R factorial. Similarly, you can do for NCR. So NPR and NCR, two things you have to remember always. See, NCR will be less always because it is n fact. Both of them have the numerator as n factorial. The denominator in case of permutation is n minus R factorial, and same thing but multiplied at the bottom by another R factorial for combination. Okay, and factorial, you know, factorial of number is, if I say factorial 5 means 5 into 4 into 3 into 1, 2 into 1. Okay, with that, let's go back to one question. Go ahead. Can you show the R Nikhil? What do you want me to? Let me share the screen. Probably I'll just to finish that thought process which I was giving them. So can you see this combination, permutation and combination formulas? Note it down if you are, and maybe I'll put this into chat window so you can take this. So we know now what is permutation combination, and we know what the formulas are. Remember this, okay? Just mug it up. It doesn't matter, because at the end of the day, you will be able to answer. That is more important as far as because this is a common thing which everybody uses. So there is nothing fancy about it. But in permutation combination, make sure that you understand the formulas, two formulas. And the other one we have already said about the probability. So let's take one question, last question. Can you, I'll stop sharing. Go ahead, Nikhil. Nikhil, are you there?
Yes. Which one should I share? Third one?
Yeah, what you do is, let me, uh, yeah, this is the one which is 7-1. Just take 7-1.
Seventh one?
7, that is probability and statistics 1. Let's
Yeah,
try.
yeah. It's I'm on that page only. Probably
Yeah,
start.
probability and statistics, the first question, let's just try to get some hang about that, so that we know that we have at least one thing which is, so, okay. So this is like, we have to go in some detail, but that's okay, we'll do it. So first thing what it says, a fair dice tossed 2 times, right? So that means a dice is taken and thrown twice. The probability that the second toss results in value that is higher than the first toss is. So what are they trying to find out? If you throw a dice, what is the probability? First probability is you will get some number, and that is 1 by 6. Correct? So now whatever that number is, we have not said what number it is. Suppose it is 1 by 6 and it happens to be some number, let's say 1. Okay. Now, if it is 1, then obviously all the 5 of them will be higher than that next time if it comes other than 1, right? Because what they are trying to do is, the probability that the second toss results in a value that is higher than the first toss is. So they are trying to figure out how you will calculate this, right? So the question will come down to how do we calculate this? It's a what do you call? So we know that 1 by 6 is the first probability. So if the first one is 1, and is there anything that he's saying the value is higher than the first toss is? So what I said is we are, if we get 1, let's say we get 1 by 6, then remaining is how? 5. Anything other than 1 is 5, right? Rest. So that will be 5 by 6. So if I have 1 by 6 and 5 by 6, should I multiply the probability? Then I get 5 by 12, correct? So the probability is a P of 1 and P of 2. These are joint probabilities. So P1 into P2. So probability of first one is 1 by 6. Second one is 5 by 6. So we get uh, 5 by 12. So the answer is C. Did you follow some logic? Some logic, maybe I may be right, wrong, it doesn't matter, but this is a guess. Now, why is it that? Because it is all probability, right? Now, what comes, I don't know. Anything I take, that will be 1 by 6, right? Anything other than that will be 5 by 6. So it will be 5 by 12, unless we again have to find out whether second one, what we got, is greater than first one. What is that probability? That will depend upon how much? That will depend upon, uh, no, how do we calculate that? I don't know. Is there any way to calculate the second one? I don't think so, because that's a probability anyway, right? Whatever comes, suppose second one is not greater, that doesn't matter, because anyway we calculate the probability. That's my thinking. But I will still try to verify that it is, my calculation is correct. We are not adding, we are multiplying the probability. That is my thinking. That is P1 into P2. The overall probability is probability of first multiplied by probability of second. So probability of 1 is 1 out of 6. Second is 5 out of 6. So we are, anything other than 1 is 5 by 6. So that's my assumption. But if there is some greater than, so whatever comes for one should be applicable for another. Because whatever we take, that will always be 1 by 6. So I think that should do for the day. We have already have 10:30. We have done 1.5 hours. So what I say is probability we will again do with all that intersection and all cool stuff. But this is something which is scoreable. You get probability or statistics, just knock it out. And these are all what you call, we can easily tell you what to do. And even if you get 2 out of this and 2 out of that, that means you already got 4-5 marks. Any positive ranking is a pass ranking, you know that. Not kidding, but uh, this way we'll collect 5 plus 5 plus 5 in every class. If you collect 5, if you have 10 classes, I think we can reach 50. And if you can reach 50, that means you are in the thousands ranking. So this is a difficult task, but let's just run, what do you call, do some, what do you call, um, effort by learning on the fly. With, so you can become on the fly. You should be able to answer right, wrong. Hopefully not wrong, but guess it right. That's it. Okay. And so, Jamit, I will, Yash, Yash, you have something to say, or Tanishq, you have anything to say? We'll continue on this. We also have calculus to cover, that is differential equation, vectors analysis, which is also related to partial differential, differentiation, integration. I don't know whether they do integration by parts. I hope not, but I'll check it out. And then you have what you call the area under the curve and all those numerical analysis and those kinds of things, which are easy mathematical scoring. And plus we can also go into gates, logic gates, and not NAND, NOR, all that, which is common for everybody, whether you are in computer science or whether you are in electronics, whether you are in digital design. So these are some of the things, low hanging fruits, which you can collect to just get the positive mark first. And then we will attempt on things which are important to score more. I hope with that I will stop the recording first. Done.